Good news, bad news. Due to a burst of enthusiasm, I'm giving 2 talks this afternoon. This is probably the more technical talk, but it's not too scary. I've been told it's sort of impolite to make your heads explode, so I'll try not to do that. But what I want to talk about here is a little bit, I mean, it is technical, but it's not technical. It's a different way of thinking about programming, because we've heard a few times today, Python's object-oriented. It's also something, an imperative programming language. Pretty much every programming language you learn in school, be it high school, primary school, after school, university. These days, pretty much every one of those languages is what we'll call imperative style. A lot of it has to do with set up some variables, run through them, change some state, things like this. Functional style is a different way of thinking about these problems. And so I just want to throw it out there as something to think about. Just before we start, I'm apparently this guy. I put my name up there so I don't forget. I've been doing Python for a while. It was called 1.4 when I started doing Python. Since they've just released, so that was 1997. I'm really old. They just released 3.3 beta now, so it's about 2.5 times better, apparently, than when I started. But it's more confusing. So Python's getting harder for me. I'm getting older, they're adding more features. It's a losing battle. So yeah, I've been doing this for a while. I've seen some change in language. There are things that are no longer in the language that I still kind of miss. I'll try not to let that leak out too much in this talk. I get a little bit bitter. Cheat sheet for this talk. It's not a university lecture. I can tell you the answers before we start. The only things you need to remember, if you want to sort of, if you're going to take half a page of notes and go something I want to look up afterwards, it's these things. The map function, the filter function, both of which are built into Python. You may not have used them, although you end up using map every now and again. The func tools module and the iter tools module, which, if I was a gambling man, I'd probably argue most of you have not used either of those. Maybe you've used iter tools. That tends to come up now and again if you're browsing around. Has anybody used func tools in real code? Really? You're not lying? Wow. I'm impressed. You copied someone, right? So you cheated. Right. And someone on the back was claiming too, or maybe he was just stretching. Oh, you have? Right. So, look. Like I said, this is the cheat sheet. These are the things to go away afterwards and read about. Both of these func tools and iter tools are in the Python standard library, which means they're in the documentation. Func tools, it's only like a page long. Your brain will leak out your nose when you read it. It's a little bit complicated. But it's only a page. How hard can it be? List comprehensions, pretty much everyone comes across them now and again after using Python for a bit, and generators, which are sort of like list comprehensions on steroids. I've only got half an hour, I won't go into too much of the difference, but just, again, remember the magic words. Right, that's the easy bit of the talk. What is functional programming? I'm going to do this because, just so we pretend we're all on the same page. But it's a little bit hard to actually say what it is, which is probably a good thing, because if I could say it in one sentence, like, it is a yellow round thing that floats through the sky, that may not be good. Well, actually, that one is good. But, worthwhile things sometimes tend to be difficult. So I cheated. You may notice a trend in a few of us speaking here. We're professionals. Problem is, the cheat isn't really very good. Programming paradigm that treats computation as the evaluation of mathematical functions and avoids state immutable data. Yeah. I mean, okay, it's a real definition. Programming paradigm, a way you write programs. Computation, what are we doing? The key bit here, if I had to highlight some words, functional programming is, amazingly enough from the name, it's about calling functions and working with the results rather than changing global state or even local state. So it's about calling functions and looking at what comes back. So maybe this is a better way of doing it. It's about we pass data into functions and we look at what we get back from the functions. We're not passing something into a function and then having all the side effects happen. I mean, side effects is almost the defining feature of imperative programming, if you like. You call something, It returns a value, but it also does some other stuff. Functional programming tends to be very down on side effects. So maybe this is probably, I mean, this is my intuition about what it is. We're interested in what the functions give us back, not about the side effects. An example of a side effect, aside from just setting a variable, is the print statement. If I call the print statement, or the print function in Python 3, it returns something, amazingly enough. It returns none. But it also has a side effect, usually. Something appears on the screen. Sometimes you have bugs and you spend a while wondering why nothing appears on the screen. But that's a side effect. It changes the screen. It doesn't return from the function. You can't tell. Input and output are typically side effects. They're the hard ones in any language that doesn't have side effects. Now, Python isn't, I mean, obviously, because for a lot of you, this might be the first time you're hearing about this type of thing, Python is not a major functional programming language in the sense that it's not the only way you program in it, it's not the primary way that you program in Python. Python's more sort of in the same family of languages as C and C++ and Java. What else do we have there? C#, things like this. Some of those languages, C#, Python, Java to some extent lately, C++ in C++ 11, have functional features in them. So I'm going to talk about some of those today. And then on the other side of the ledger, we have languages like Haskell and Scheme and Lisp. And amazingly enough, JavaScript is a reasonably functional language, although it's never pitched that way. Because again, your head explodes and people stop using JavaScript, and that's not cool. So, but it is, you'll see, a lot of JavaScript is about calling functions and looking at what you get back. jQuery particularly is a very functional way of programming JavaScript. So if you've done any sort of jQuery work, you've done a lot of apply this function to a whole bunch of data structures, and then look at what I get back, and then apply another function to it, and so on. In Python, so here's where we start diving into, okay, I've told you what it is and what it isn't, let's actually look at the concrete examples. The big deal about Python is functions are what we call first-class objects. Doesn't mean they get to ride up the front of the airplane. It means that we can treat them as objects. You can hold on to a reference to a function. You can pass a function around to somebody else. You can assign a function to a variable and then read it back out again later and call it. A lot of languages do let you do this. It's not maybe so well known. You can do this in C and C++. Don't do it too often, but you can do it. Java's a little fiddly to do it, but you can kind of get away with it. Again, JavaScript is a big example if you're familiar with those, where you can do it because you're constantly passing callbacks to functions in JavaScript. But the big point, if I have a function, and we'll see an example on the following slide, some function called foo, I can pass to around. If I refer to foo, it is the function object. I can pass it around, I can assign a different function to foo, I can assign it to a different variable, I can make 2 copies of it and throw one away later on. I can call it whenever I want. So this is the function, it's not the result of the function. This is very important for functional programming because it means I can pass functions around like they are arguments to other functions. And that's a lot of what functional programming is, pass function to something else. I can also construct them dynamically. I can make up a new function. Whoa, that was really cool. Right. Let's keep moving slides faster than one every 5 minutes. I can make up a new function as I go along. I can, define inner functions and pass it back out to the outside world. Again, none of this is, you don't do this and you think, gee, I'm doing functional programming. I'm scared, stop. You just do it. So here's an example. This is probably the most densely packed slide in the deck. I'm sorry about that. We have a function, the top one. I'm very bad at naming things. We have another function that takes the showString function. So my function at the top just returns a string. The showString function has a side effect. It prints something, hopefully. It takes, again, I'm trying not to be tricky here. It takes one of its arguments is called func, meaning it's a function. It's not called function because it wouldn't fit on one line in the slide. But it calls the function. It takes whatever that returns, adds argument to it, and hopefully it returns a string, so I've got things that I can add here. Plus in Python for strings is concatenation. And so we can get something like the prompt out here. I call the showString function, I pass in my function, and goodbye, and I get back what I expect. Nothing too surprising there. If I didn't highlight it, you think that was perfectly normal. But that's, my function there is being used as a first-class object. It's being passed around as a parameter. Useful things in Python that you might not know about. Lambda expressions. If you're anything like me, it will take you about 2.5 years of learning Python to learn how to spell lambda properly. That B is a real sucker. And I say this, I have training as a mathematician, so I actually kind of know the Greek alphabet, and I still screwed it up for years in Python. It's kind of embarrassing. Maybe you're not like me, maybe it's only me. But anyway, lambda expressions are a way to create anonymous functions in Python. Anonymous meaning they don't have a name, they're still objects. What gets returned from that example, the lambda 1 plus 2 line, is a function, is something you can call. It's a function that takes 2 parameters, called 1 and 2, and it returns 1 plus 2. What Python doesn't have that a lot of other languages have is what's called multi-line, like block closures or multi-line lambdas, sometimes you see in Python. Guido van Rossum, who made a guest appearance in a slide earlier today, has really put his foot down on that one. There will never, ever, ever be multi-line lambdas in Python. This is not a horrible thing. It's, if you want to program Python in the style of JavaScript, we're really used to in JavaScript being able to create anonymous functions. If you come from the Ruby world, it's easy to create anonymous blocks, anonymous closures in Ruby. In Python, just create a function with your own name, def, whatever, foo, and write a function if you want moduli functions. You can have functions inside functions, it's not a problem. So Guido's sort of been fairly consistent about that for the last 20 years. There's some other things that he said never, ever, ever, and they happened. So maybe one day, but he's been pretty consistent about this one since the early 90s. In the functools module, which I mentioned earlier, we're not subtle about naming things in Python. This is a module with tools for working with functions. There's a function called partial, which is what you give to partial. You pass in a function and a few arguments, the first few arguments, or maybe a couple of the named parameter arguments. And it returns you a function that already has those applied. So later on you just have to call that return thing and pass in the missing arguments. We'll see an example of that later on, but it's basically a way to sort of say, okay, I want to fix a few of the arguments here. We didn't have this until Python 2.5. Back in the old days when dinosaurs roamed the earth, you had to do that sort of manually, but it wasn't really painful. It was just that it took you 3 lines and it really only took you 1 line, so in 2.5 they added the functools module. And then there's the itertools module, which is very useful for dealing with list comprehensions, generators, iterators, how to combine. If I've got multiple iterators are things that I can iterate over, amazingly enough. I can go for I in some iterator. The itertools module allows you to combine these, allows you to chain them one together, allows you to have both of them running at once, so it returns a pair of things each time from 2 iterators. Worth reading the documentation on that. If you really like hearing me speak, there's a video on YouTube of me talking about iteration generators that I gave 3 weeks ago in Singapore. Possibly wearing this exact same shirt. I do have more than one shirt. I just realized. And look, that's another half hour. I could talk about those, so I won't. Here's an example. This is not a good example. This is, we are going to improve this. And I'll point out, Audrey and I did not speak before this morning, and we both chosen the same example here of working out even numbers. Python is a bit more powerful than being able to do just this. It happens to be a nice example that fits onto a slide. So, in my case, we're wanting to pull out all of the even numbers from a sequence. SEQ here being an abbreviation for some kind of sequence. I tend to be, my programming tip, and this could just be me being me, but whenever I pass in something that is a sequence to a function, I tend to call it SEQ rather than my list or my tuple or my dictionary, because many things in Python support the sequence protocol. You can iterate over them. So this is just saying, I don't care what you pass in, it needs to be something I can iterate over. 3 lines in, I'm going for item in my sequence. If it's even, add it to the result list and return the result. So it returns a list of things that are even. Alright, that's 1, 2, 3, 4, 5, 6 lines long. We're going to get down to being able to do this in 1 line, or half a line actually. So it gets better. First obvious thing here is, well, I don't know if it's obvious or not. The if statement there is a bit, for something in a sequence, if something, add it to a list. Again, we all got to do this. This is the way we did it in the old days. We got a bit sick of doing this around Python 2.1, I think, or maybe 2.2. We added list comprehensions. So we've gone from what, 6 lines here to 3 lines here. List comprehension is, I mean, even if you do not know what list comprehension is, hopefully the syntax is clear. You might not be able to write your own, but you should be able to, if I tell you that is a believable, syntactically correct line of Python, you should be able to work out what it does. And again, I'm using maybe slightly unfriendly variable names here, just because I need to fit on one line. So the list is all the values x that are in the sequence if x mod 2 is 0. A generator, by the way, is if I replace those square brackets with parentheses, rounded brackets, I would get back something slightly different, not a full list, but I get back something again. I could iterate it. And of course, I can make that a one-line statement by not assigning to result and then returning result. I can just go return blah. But I just wanted to make one change at a time. I can do a little bit better than this even, because this turns out to be a fairly common, I mean, list comprehensions are powerful. That's probably the first thing. If you don't know, if everything I'm saying here is new to you, learn about the map statement in Python and learn about list comprehensions, because they're actually surprisingly useful. But we can go a little bit further than that, because that's a fairly common thing of apply what's called a predicate function, like apply a test to a whole bunch of elements in a sequence, and just give me back the ones where the test passes. Oh, actually, okay, slight shortcut here. What I would like to point out here is there's nothing special about, back here, there's nothing special about x mod 2 being 0. That's just a test. So let's pull it out into a function. Those of you who are still awake will probably notice it hasn't gotten any shorter from the last slide. There's an argument it's gotten longer. I'd buy that. But we're refactoring for the greater good here. Part of the thing here is function of the first class object. I could replace is even with anything. I'd probably want to rename it because it would be stupid if it was testing for odd values, but it's just a function at this point. And now it's a test. It's just a testing function. So I can use, okay, we've still got the same is even function here. And I'm using the filter function, which is a built-in in Python. The filter function takes a predicate, a test. Like the first argument to filter is a function that takes one argument and returns true or false. It can be any function you like. And it runs through everything in that sequence. In the second argument is a sequence, something you can run through. And it returns a list of all the things where the first function returns true. You can imagine these predicates could be quite complicated. You know, I'm just testing for even and oddness of numbers. My sequence here could be something much more complicated. You know, a whole bunch of protein structures or I don't know, economic indicators or something like that. My predicate function could be something that takes quite a bit of time to evaluate. It will still return me all the things that are true. There's also something I should also point out here. Filter returns me a list, which, big surprise, who cares? The point being it constructs the list in memory. So if I'm getting back bajillions of results here, well that might not be a number, but billions of results, that might be uncool to store them all in memory at once. In the intertools module, which is the other one I brought up earlier, there are things that, there's a function called take while, no, not take while. There's a function that is similar to filter that returns you an iterator. It doesn't put it all into memory at once. It allows you to pull them off one at a time, which can be useful if you've got mega numbers of results here. Finally, I can simplify this maybe a little bit more. That is evens. Remember back here, we've got a function that takes evens is a function that takes a sequence. Here's where I claim I can get it down to sort of half a line. I have my predicate, which could be anything. It's just a stand-in here. It's doing a very good job. And here's how the partial function works. I give it the filter function. The first argument to filter is another function that is the predicate we apply, and this partially applies it. And all this means, it doesn't really, I mean, it doesn't partially apply it. It still needs the second argument to filter the sequence. But it says evens is now a function that takes a sequence and does the same thing as it does back here. Filter applied to is even, with is even as the first argument and sequence as the second argument. So this means I could now do something like this. The first line is just what we've seen before, but evens is now a function that takes a sequence and returns what I'm after. nothing, we can get by without the partial function. We did for many, many years until Python 2.5 came out. Maybe 2.6, I can't remember the exact one. They all blur together after a while. But it's a nice little time saver if you've got complicated code to be able to just, writing a function like evens, if I was going to use that a lot of times, it's a nice case of being able to simplify my code. Readability does matter. I agree with various earlier speakers here. But I'll point out, evens is something that's a little bit mind-blowing if you stop to think about it. So don't stop to think about it. No. It's a function that takes another function that takes a function as its first argument. So it's elephants all the way down here. The first line, we're making a function out of 3 other functions being combined together. That's functional programming. It's not just we use the word function a lot, we are applying functions to each other. So partial is, again, learn something about partial, have a think about, can I use this in my code somewhere? Because it's kind of useful. Finally, the types of things that functional programming is a lot about patterns. And it's not appropriate for everything. It's fairly hard, for example, to write a game in functional programming style because games are all about side effects. You want to display things on the screen, you want to get back input, you want to do output, things like that. It's not impossible, but you have to stretch the definition a little bit. But there are some things that come out really, really nicely in functional programming. One I'll point out that's not in these slides is if you've ever heard of MapReduce, which is an algorithm that Google sort of made famous, but is a fairly popular sort of algorithmic style. That's a functional programming algorithm, if you like. It allows you to parallelize things very easily, run a whole bunch of computation on different machines that are all independent of each other because there's no side effects. It's just what you call the function on, and then combine the answers together. So mapping is doing all the function calling, reduce is combining the results. And that's these type of transformations. Applying, in all of the following slides, we have a collection of data. Think of it as a list of numbers, or a collection of economic indicators, or a class, a collection of class instances. One of the things you can do is apply a function to every element in that sequence and return a sequence that's of the same length, or perhaps with some things thrown out. But basically, we change every element in the sequence, and we can still get back another sequence. Map is very good for that. Map is a function that the first argument is another function. The second argument is a sequence. Apply the first function to every argument in that sequence and return the resulting sequence. List comprehension, which you've seen before. Generators are more or less list comprehensions. You can think of them as the same thing, except they don't construct the list in memory right up front. They do it on demand as you call elements. So generators are a little bit harder to work with, but much more memory efficient and sometimes easier to reason about. Selecting elements from things. I have a sequence, I want to take a certain number of elements. It could be I want to take all the elements that meet a certain predicate, a certain test, that's a filter function. It could be I know my elements are in some kind of order. Don't start paying attention until I hit some point. Well, that's the drop while function. Its first argument is a predicate. Again, it pulls the elements off the sequence one at a time, and if the predicate is true, it throws it away. So, I could be testing, my predicate function here could be test if the value is less than 10. If it's less than 10, throw it away. And if I've got a sequence that's 1, 2, 3, 4, 5, 6, 7, 8, 9, so on, it throws away all the first 10 elements and then keeps the rest. Take while, again, we're not really good at naming things here, so we're not very tricky. It takes things off the list while the predicate is true. And the while bit is important here. When it gets to something that is false, it stops. It doesn't then, it's not like filter that keeps looking for other things that are true. It says, keep taking things until you find the first failure, and then stop. So there's examples from the editorial module that are useful, out of about 17 different things now. Combining elements. I have a sequence of things, I want to come up with one number. This could be, I have a bunch of population counts, or I have a bunch of, again, I keep using the economic indicators, but I have a bunch of numbers that I somehow want to combine them, perhaps by addition, perhaps by something a bit more complicated, averaging, but I want to combine them down to a single value. A value here might not be a number, it could be a more complicated structure, a tuple or a dictionary or something like that. This is, in the literature and in the, around the internet, this is called folding. Because if you think about it, you're sort of folding all these values into each other. Think of it folding like baking, not like origami. Although sometimes the code looks like origami at the end. Reduce in the functionals module is a good thing here. Reduce used to be a built-in. and Guido got thrown away, basically. Reduce was being abused a bit by people to basically add up lists of numbers. So they threw away reduce from built-ins in Python and put the sum function in, and they moved reduce to the functools module. So you have to use it intentionally. And manual loops here, I mean, not everything is a one-liner. Sometimes just writing a manual loop, go over the values, add them up as you go, or combine them as you go. It's not a bad idea. Unfolding is the opposite of folding, amazingly enough. But I mean, what does that mean? We can all understand intuitively, I have a sequence, I sort of fold them up to be one number. I average a list of numbers, for example, or I sum a list of numbers, or finding the maximum of a list, by the way, is an example of folding, because I keep going through the list one at a time. I have my current maximum, I look at the next value. Is it smaller? Okay, I keep my current maximum. Is it bigger? Use that as a new maximum. Keep going through the list. By the end, the value I have left is the maximum. Unfolding is a bit more counterintuitive. I have one value and I want to sort of explode it into a list somehow. Well, there's no obvious way. If the value is 17, what is the list? Well, this is, there's obviously many answers to this. But think of this as a seed, and then you feed it to some kind of generating function where you turn the handle and it spits out the next value. So the seed could be the initial value of the sequence. The generating function could be, keep doubling the previous value. So I put in 1, turn the handle, it gives me out 1, 2, 4, 8, 16, and so on. Or it could be give me the next prime after the previous value, or something like that. So there is unfolding does make sense. It's not completely ridiculous. And sometimes it's useful. You think of it as, I give you a value into my function, which is a machine, and it spits me out a sequence of values. Very useful when you're generating random numbers, prime numbers. You see it a lot in numerical analysis. You see it a lot in simulations. Manual loops tend to be the way. There's no sort of built-in cheats there because there's so many different ways to do it. Recursion is sometimes useful for very big sequences. You start to hit Python's recursion limit. You can only sort of do a depth of 150 or something before it gets upset and throws up at you. But for smaller values, it's useful. Well, we ran out of slides, and no one's headed to it. Really no one's obviously sleeping either. Okay, I have 2.5 minutes left. Right, someone's going to have a question. Somebody else out of the front row has to have a question. All right, Danny, what's your question?
Okay, so generally we've got class space, and one of the things that I explored not too long ago was using stuff similar to this instead of being functional and
Right. So the question is, in Django, we have this thing called class-based views, which are a well-loved or well-hated, depending on your point of view, way of constructing, a framework for constructing HTML output. Danny's question is there a way to do this? Like he looked at exploring doing this with sort of a functional way to do this. Does it make sense? Unfortunately, the answer is it depends. It depends on how you want to do it. There's probably a way it makes sense. It makes sense to do view-like function in Haskell or Scheme or something, so there's probably a way to express it in Python that isn't crazy. Is it a good idea? There's probably also a number of bad ways to do it. Sure there are. Is it a good idea is a little bit riskier because not a lot of people think like this normally, and particularly not a lot of people doing web page design think like this, so maybe it's a moderately crazy way of, it's not a comfortable way to do things in a library that's meant to provide support to people. On the other hand, maybe there's a really nice, obvious way to do it. Again, a case of we do all the complicated stuff in a library so that the users of the library don't have complicated, don't have to worry about the complicated. Any other questions? I will put these slides up somewhere when I have internet tonight and probably tweet about it or something so that people will know if you want to read this. I'd also say, like I said, I'm not just self-promoting here. I did do a talk on iterators and generators a couple of weeks ago. If you search for my name on YouTube, I think PyCon Singapore have already put that talk up. So that, it might be worth watching, and that talk has some references to other talks about iterators and generators. You can spend most of your life playing with this sort of stuff. I don't recommend you do, but it's fun. This is a worthwhile thing. It's not just a toy way of programming. It's a worthwhile, broaden your mind. Don't just do one programming language in one way. Okay, I'll be back later.